Oh, hello.
Hello.
Oh, we're the only two on.
Only two so far. Oh, more coming now.
Oh, yeah.
How's life in Eastern Canada?
It is slightly above freezing and a little snow today, but other than that, it's pretty good.
Cool.
How about in Western Canada?
Exactly the same. It's kind of piddly rainy, 0, -1, really nice spring.
How about in Australia?
Oh, freezing. It's about 25 degrees. So, yeah. No, it's actually quite nice. Yeah. Oh.
So, what's happening there in terms of crops?
No.
In Australia,
Yeah.
we're about to start cropping. I suppose we're about 2 weeks away from pulling the gear into paddocks, into fields, and and then it will be starting. So we don't get any rain until winter, so probably another month away from rain. But yeah, everything will get dry seeded and then planted. Well, planted first and then dry. So yeah, I don't know. It's normal.
Neat.
I'm getting feedback.
Yes.
I'm getting a little bit too. I'm not sure. Brian, are you getting feedback too?
I could just, when Andrew was talking, I could hear a little bit, but I could mute one.
See if that makes sense.
I don't know how many people will be on today, but
Yeah, I was a bit late notice, I suppose. I should have put it up a day or so earlier. It might have helped.
unacceptable.
Yeah.
I saw you were on the Ross forum, Wilbert.
Yeah, I just chucked a couple of things up there. I was joined in on the meeting last Tuesday, and well, you had asked if anybody had any input on the TIND IMU, and I figured those guys might have had some insight there. So I asked them. There's a couple guys that had used components of the IMU, but not that specific one together.
Right.
So, verdict's still out. Did you get yours in the mail?
I did. I didn't find an Arduino code for it, so I'm gonna have to modify from an ESP, or add just one more freaking thing to do. But I don't know. There's so many branches here. I got a good start on that rate thing, and I can read everything, read the bitmap, except like AgOpenGPS is on like an XY, right? And except the bitmap is read upside down. So I have to invert. Not completely. You can't just read the bitmap backwards, because the bottom line needs to be on the top line, but then as you go across the line, that has to be in the same order. So I have to invert the lines so that it reads the bottom line first and the top line last, but then linearly across the bitmap. So it's like a half of a picture inversion. I suppose a guy could just flip it in graphics.
Paint or something.
Yeah, just turn it upside down. Oh, that sounds easier than coding it all. For now. But then it's one more step for people to do in a graphics program to, have to flip it. So
how would that work, do you think, as far as a rate when you're going, let's say for the farmer, he comes in with a shape file, what would he have to do what do you envision how that would work?
Well, all I did, I don't know, like, remember there's the one that you posted from CropStat, right?
Yep.
I just, the smaller one. I just took and then imported it into Google Earth, and then exported it just as a JPEG, and then just converted it to a bitmap. And then in Paint, I just took and made the. Can you see my screen?
No.
No, shit. Sorry. How do I capture the screen? Where's the bottom here?
Alt S, I think, gets you the shortcut to get there.
Alt S. Oh, there we go. What do I want to be? Man, it's hard. There it is. Share. Now,
Yeah,
can everybody see it?
now. Yep.
Because remember that there's this picture on Google Earth, right? And I just saved it as a JPEG, and then I just used Paint, and then selected just around the edge of the borders, and then so then that basically becomes. Okay, now I have to go back again. Oh, stop share. See, we're way more fun than the Ross group.
Hi, Matthias.
Hi. Can you hear me? I have some trouble with the hardware.
Oh, I can hear you.
Oh, hello. Feedback.
You have a little bit of feedback too?
Yeah, I think it's gonna be okay now. Yeah. Hi, I'm from Germany.
Hi.
I'm Matthias Hammer. The first meeting I came a little late, and so I missed the introduction time.
Okay. I don't know if we did the full introduction, but I'm Wilbert Talon from Prince Edward Island, Canada. And Andrew, maybe you want to introduce yourself too. We'll do that now, yes?
I'm Matthias Hammer. I'm from south of Germany. And yeah, I'm using AOG for section control. And in spring, I built an autosteer system on my vineyard tractor. And I used it a little in the field, but yeah, I need to improve it a little. It's not working as good as I supposed to.
Very good. Andrew, would you like to introduce yourself too?
Oh, yeah. Yeah, Andrew Martin from Geraldton in Western Australia. Just a user of AgOpen, I suppose. It's just really appreciative that Brian made it available. And yeah, we tried a few changes. We managed to crash the program quite frequently when we make changes, but yeah, I think it's yeah, we enjoy being part of seeing the development of this.
Would I be right in saying that your son is also involved in some of the coding? Is that correct, Andrew?
Oh yeah. Travis he's not actually here at the moment, but yeah, he's quite well. He's better than me at coding, so I guess passed it on to him and tell him what I needed, and he's done a couple of little jobs for us that were specific for us, and yeah. He'll see this later. He's given me a ask, but yeah.
Very good. So Matthias, I don't know if you caught that, but Brian was just showing us the variable rate or the rate control that he was working on just recently and showing us how that was put together. So he was just getting set up. So maybe if you want to take back over again, that would be great, right?
Yeah, it crashed trying to bring up OpenGL crashed Zoom, so that's why I disappeared there for a bit. So maybe I can't show. Is there a way just to share my whole screen?
Sorry, wenn's nicht genau. Nächstes Mal noch. Okay.
Ja,
Ciao.
Whole screen?
Here, let's try that. Can you see path planning?
Yes, we can.
Okay, let's see if. Oh, that doesn't work at all. You still hear me? Can
Yep.
you see that now? Like that map?
Yep.
Okay, good. Now it's got my computer. Hey, just catch Matthias up. There was that crop set picture, and just imported it into Google Earth, and then created an image from within Google Earth. Thanks for the tip about the templates, Wilbert. That makes perfect sense. And what I did is then the maze part of, I don't know if I ever talked about maze much, or remember the maze is an XY group of points, and it doesn't matter the orientation of the field. It just creates a grid. So I thought, well, if a picture is a square grid as well, and this is exactly how it makes the maze, why don't I use the same basic code that from the maze, and then use the individual pixel points as the rate. So of course, you know, where it's black will be 0, and this is halfway, so this is like half the rate, and white would be wide open. So it'd be a fairly simple concept. I wish I could get AgOpenGPS to work though. It won't let me bring up AgOpenGPS, which is.
Oh, to share that screen at the same time, you mean?
Yeah, see there, you can probably see the code. But it won't let me bring up AgOpenGPS. Oh, that's because it's not running. There, okay. Now you see the red dots and stuff on yours? You see a field?
We see a field with lines through it, 1640 at the top for the white bar, and that's overlaid over top of your PowerPoint.
Oh, shit. That OpenGL really messes up Zoom.
Oh, okay.
But anyway, I think you can understand, like basically just trying to overlay the image over top of the field. And then wherever you drive, you correlate a pixel now to a position. So when you drive over that position and you find out you have a map of positions instead of map of pixels, and then each pixel value then becomes your rate. So now when you drive over that pixel, you set your rate whatever that pixel is. Does that make sense? And then as you drive along, as the pixels change, your rate changes. Maybe it's too simple of a concept, but I don't see why it wouldn't work. Everything about AgOpenGPS is simple. So, I mean, you don't need shapefiles or anything. You can go into Google Earth and save a picture of it. And this is what I did yesterday. I don't know if they're here or where they are. I just painted where I wanted a different rate, like in a valley or whatever, and then the rest of the picture would be all white, which means it's full rate. And then where it's like a gray or a lighter color, then that becomes half the rate. So I mean, talk about poor man's VR. But then we can import shapefiles and created files from SMS or whatever in Google Earth and export them as a picture, and then just import that picture into AgOpenGPS, or just add it to the directory. Just call it vr.bmp, and then that becomes your variable rate for the field.
How would it link up as far as overlaying on, as far as coordinates? Like if you wanted to line up your field boundaries with that BMP image, how would that link up?
Well, I wonder if I could bring up Google Earth.
That'd be OpenGL again too, wouldn't it?
Where's 8? I'm so unprepared here today. Here, let's get rid of about 97 wind. Boy, so much open.
Okay.
Okay. doesn't work. I'll try to open Google Earth. Let's go through the whole thing so that it makes sense. Can you see Google Earth coming up?
Not yet.
Can you see it now?
Nope.
No. But we do see your desktop with the tabs on the bottom, and I see Google Earth Pro is at the bottom middle, but that's it. We see AgOpenGPS overlaid over top of the PowerPoint.
Shoot. Now you see Windows Explorer again?
No, still the same screen.
Shoot. It's probably too much for Zoom, hey, to try to open 11 windows.
Yeah.
Fields. Oh, that doesn't work. Sorry, guys.
No worries.
But I think you get the idea. Like in terms of, all you need to do is draw a box around where the field boundary is. You know, and then, I mean, that's kind of the only tricky part, but it's not really that tricky because you can, do you see the photo now? The field map of the field again?
No.
Here, I'll just stop sharing. Maybe that. Wilbert's way better to look at.
Or you could point your webcam at your screen. That might work too. You know, unless it's on a laptop.
Oh,
Yeah, that would work.
On a different laptop on my desktop. Next meeting, we'll do that.
That might
And
work.
then it just has
Good
to see
idea.
the webcam. That's a really good idea. But basically, you just shrink the thing, you select it so that you're making a square around the field. Because remember, you're trying to put a picture, that can be any random shape, right? Just as long as you're at the X min and the X max, Y max, and Y min, you just draw a box around that field. Because now you're just overlaying that picture. And it doesn't matter what how many pixels wide it is. You just expand the pixels, either make it bigger or make it smaller, and then overlay it over top of the field. And that's the same way the maze works, is we're creating a grid of points, and then we're deciding whether or not what's the shortest path, you know, on points that you can actually drive. So it all kind of overlaps the same. And technically you could have the maze and you could expand the data of the maze to include more rates. So like if you had the XY position of the maze point, and in that maze point you added rate 1, rate 2, rate 3, you could technically have as many rates as you want for each of those grid points. So
Pretty slick.
yeah, let's try, oh, don't delete Zoom, that would be bad. I'm gonna try to delete a bunch of stuff here. And that all ties together with that, so you can see path planning again?
We just see you, Brian.
Ah, okay. Where's Zoomy? Share. The screen. Share. Now, do you see path planning?
Yes.
Yep.
Oh, good. Okay, let's just stay here. This is some presentations I did. Okay, so path planning. We'll jump into this and kind of finish this, and then this will help make kind of sense. Like I don't know about you guys, but we don't have fields like this, where they're nice square fields, right?
Yep.
Yeah.
This is a typical field where you have edges and you have, you know, sloughs and trees and areas you can't drive, that sort of thing. And Agribot originally has this, and it was just a way, this Boustrophedon Decomposition. What that means is, Boustrophedon means the way the plow follows the ox. It's actually ancient Greek. And then decomposition is to break a field down into smaller manageable chunks. If we think about the way you do a field, like if we're going to do a field like this, you might start here and go back and forth, and then you go here. Can you see my mouse move back and forth?
Yeah.
Yep.
Then you might do this part, come around, and then do this part, right? And then go back and forth all the way across the field. Then you have all these individual little fields, basically, right? And the big word, Boustrophedon.
That's someone's dog there. Not mine.
Not mine either. What Boustrophedon decomposition means is take a big field and break it down into a bunch of smaller fields. So here's a picture of like exactly what I said, like doing the field. So if you just let AgOpenGPS run with auto headland, it'll go back and forth, do this, do this, do this, do this, and get across the field. Now you're left with these other chunks. But mathematically, that's the really hard part, is to figure out where all these chunks are. So, and again, it's very much the way we do a field. So Moore's decomposition, fairly math intensive, but I'm not that good at math, as you know. So what the mathematical part is, you move this slice along, and then you get to a point, and when you're exactly 90 degrees to the tangent of the line or parallel to the tangent of the point with the slice, then that becomes a point. And you can see as we move across, where this delta, or that, I don't know what that symbol is, M, you can find these different points as you move along. So those become the critical points. And then this slice for determining the tangent, guess what that is? In your field, what do you think this slice is?
It's the AB line.
Ah, exactly. So I thought, well, geez, we can simplify that. So now you create these different fields based on these points. So as you go across, you figure out how many points of intersection there are, and then you create these fields, like this pink field, the yellow field, the green field, and then you just do the individual fields. And now you've created from this one weird shaped field, you created 1, 2, 3, 4, 5, 6 different fields now. So then you try to cover each cell. So I thought we should be able to do that with just a straight AB line. And then as our AB line changes as we go across the field, we can see that. And then, I don't know, it's pretty small, but do you see this chart on the side?
Yep.
The first field, I even forget what I did here. It has 3 lines in it. So 1, 2, 3 lines in it that are complete. Then the other part has 6 lines in it. And there's, it says 1, there's actually 2 fields. And then there's 1 field. And then there's 2 fields. And then there's 1 field. So like there's 0 interruptions in these AB lines. And so from this, you can start to create these individual fields based on that decomposition of obstacles. So now that becomes a field, that becomes a field, that becomes a field, that becomes a field. And then, so basically that's about as far as I got. And then here's a field with like 1, 2, 3 different separations in the field. So basically all you have to do is figure out how to create these as fields. But you can see in something like this, it gets pretty complicated because now you have going all the way across here, and then there's kind of one here, and then there's one here, and one here, and one here. But I mean, that's a fairly complicated field. So I got to this point where I could figure out how to get the individual fields out of the field. But then I was like, well, if I'm here, how do I get to here? If I'm going to traverse from this field to this field, AgOpenGPS would just want to go right across the boundary. You can't do that. So that's when I started down the path of mazes and trying to figure out how to get around this stuff. So that's what, it's a side branch, but it's really, really important to be able to drive around stuff, right? So there's a maze in Manitoba. They made it out of snow. It's kind of cool. Oh, how does a maze work? The way to solve a maze is you go to the goal and then you just count back to the start. So going around this way, go 10, 11, 12, 12, 13, 14, 15 to the start. And this way around is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is the shortest path. So what you do is you count backwards all the different possibilities, you know, back to the start, and you pick the shortest one. And that's what the maze does. So now, what does this look like? A field, right? Here's our outer boundary around the outside of the field. It's a nice square field. And in the center, we have a slough or bush or whatever. And so we number those individual cells to be not drivable. In this case, we call them a 1. And then, so if we start here, we go 2, 3, 4, 5, 6, 7, 8. You can see there's a couple different ways to get back to our goal. So voila, there's our 2 paths. And they all go around. If we didn't have obstacle collision, we'd go from 2 straight to 18, and that wouldn't work. So, I don't know, probably I've posted this before. So the red dots are areas that you can't drive, and the white dots are areas that you can drive. So what it does is you have your start point and an end point, and then it just does all those maze calculations. Can you see this video? It doesn't matter, but you've seen, you've used it before, where, you know, we're starting here and we're ending here. It just finds a maze path, the shortest path to that point. So that's kind of where I'm at. Now I've got the Boustrophedon decomposition to create these individual fields and a way to avoid the obstacles getting from field to field. So it's getting close, but the Boustrophedon it's complicated stuff, like to be able to create fields. A lot of that is used in automated office cleaning equipment where they have like big versions of Roombas, and then they break the office down into these individual little areas, and then they just complete the areas. They can't do random in office because they have to get done and get out of there. So the technology exists and it's out there, and it's actually proven technology. So then in terms of rate, go back to this guy. Rate, we're doing exactly the same thing. We're just creating a grid of points, and then now that point has a value from 0 to 255, which is like the color that you see. And with different colors, you have different rates. And with that different color, you can create an index from 0 to 255, or from 0 to what's 24-bit is what, 3.8 million. You can have all these different levels of rate based on what the color was. So we're just overlaying a bitmap over top of the field the same way we're doing the maze grid. Does that make sense?
It should work. Just a question.
Yep.
Does it affect the section control? Do you use 2 graphical layers for this?
It wouldn't, because I'm only showing the dots. It doesn't use graphics at all for the rate or the maze. It just uses points on the field, the same way it would use boundary or determining auto turn lines, that sort of thing. Hey, Andreas. It's purely mathematical, so it doesn't affect section at all. This is just so we can visualize where the maze actually is. I can't run AgOpenGPS.
Can the user see the rate stuff when driving in the field?
Sorry, ask that again, please.
The user can the user see the graphical rate file on the screen while driving?
Well, like in, you know, the rate tab where you set your rate for the sprayer stuff.
No, on the screen on while driving in the field.
We can add that.
Vehicle.
But like the rate display, you know, on the left-hand side where you have the buttons, or what's it called? You know, the Batman, like not the one that's shown right now, but the other one, the one that shows with the 4 tabs, and there's a rate tab. You hit the rate tab, it shows you the rate and what the accumulated volume is and that sort of thing. I mean, you could put the rate anywhere, and then as you drive along, I hope to be able to figure out inverting that picture. And I think I'm going to just cheat at first and just invert the picture in a graphics program. And then I'm just going to put a number here. And then as we drive along, the number is going to change. And if we got a changing number, you can display and do anything you want with it. The trick is to be able to, as you drive along, to be able to get that changing number. So yes, no problem. That part's easy stuff. That's just simple GUI stuff at that point. Does that answer your question?
I think so. Yeah, it's okay.
Probably not, but.
So, Matthias, were you suggesting like kind of like we see on your screen right now, Brian? Like we see where the obstacles in the center are.
Yep.
And we can see the different colors of the grid.
Oh, yeah.
Yeah, that's what I want to ask.
Yeah, okay, perfect. Yeah. So be able to maintain the dots on the screen. Like, these are just points, and we can make those points any color. You'll still be able to, and you should be able to just turn them on, turn them off if you want to see what the rate is. And you could kind of ghosty blend those dots in. Yes, definitely.
Yeah. Because I think if you were driving on your fields and you could see it on AgOpenGPS, oh, I'm coming to a yellow section, for instance, so I know my rate is going to change, and then seeing the rate change as you drive over it. With that, I think that would be the same thing, right? It's viewing the grid as we see it now.
Yes. Yeah, I mean, you can make those dots bigger, smaller, and as you zoom in and out. And then you know how, like, when you drive over a section, or you have the mapping from the section, then you drive over it again, and then it's darker or lighter, and then as you drive over it again, it's lighter again. What that's called is called blending in OpenGL, where you have the alpha value, or how transparent that is, and the more transparent it is, the lighter it is. So then when you drive over it again, now you have a source alpha and a destination alpha, and you add those together. So now you have, say it starts out at 20% alpha, right? So that means that 20% of the colors you see. Now if you drive over it again, now it becomes 40% transparent, or 60%, or 60% transparent, 40% opaque. And then you drive over it again, right? Now it becomes 60% opaque. Like you can see 60% of the color. That's why when in AgOpenGPS, when you drive sections over sections, it's like you drove over it again. But graphically, all you're doing is just changing what the transparency of that pixel is. It's not like adding more pixels, because you can only have one pixel on a 2D screen. But what you're doing is you're changing the transparency and how the background is behind it. You turn transparency off and on depending on the different layers. Then you have it's called Painter's algorithm. You start at the farthest thing, which in this case is our grid, and then our map, and then our sections. So now you turn transparency on, do the sections, and then when you're done the sections, drawing the sections, then you turn transparency off again, and then you draw your vehicle and your AB lines and your boundaries and that sort of thing in these points. So again, as always, there's an awful lot going on behind the scenes, but you can see as you pile these pixels up, the pixel value then becomes the addition of all those different layers. And then you're left with an image that you put on the computer screen.
Okay.
Very cool.
Yeah. That's the way every game works. And it's called Painter's algorithm, because a painter, when they make a picture, what's the first thing they draw? They draw the mountains and the clouds, right? And then they draw the trees in front, and then they draw the house, and then the person standing in front of the house. And that's exactly the way computer graphics work. You put your background in, and then you just draw as you come towards the camera, and then you occlude the pixels that are in behind. Slightly off topic, but an important topic. So in answer to your question, Matthias, yes.
Yeah, this is the answer.
It's a long way to say yes, but.
Just another question. When talking about layers, we discussed about tram tracks, tramlines. I don't know the English word.
Yeah.
And, would it be possible to draw them in a different color and reload them later, because some vehicles will only drive on the tram lines. So it would be we would be able to activate drive only in tram lines, and that would be very cool.
Well, the tram lines are generated from the AB line. If you've saved your AB line, then it should be able to. You know how the guidance lines come up? You know, the guidance lines, extra AB lines on the side. You technically it would take some programming to make the right colors. It's certainly possible. Yes.
Okay. Perfect.
Yes.
I think it would be cool to when seeding at 3 meters and needing tram lines for 15 meters. So the seeder should be activated to seed the tram lines, and this one should be saved. So later on with the sprayer, I only would seed the AB lines with the tram lines.
Have you used the tram function with the AB line?
No, not yet.
Because you can set your starting one and how often the tram line appears. And the tram line appears in green, and the non-active tram lines show up in, man, I wish I could use AgOpenGPS. I find it kind of frustrating. You guys can still see my screen, right?
Mm-hmm.
What happens when I do? What happens when I do this?
We can see it loading. Yeah.
Do you see AgOpenGPS? You can see it?
Yep.
Yeah, it's funny.
So here's that VR field, and I have it so that when I do U-turn, you see how the bitmap's all messed up? But that's basically, here, I'll just stop. Can you guys see the map?
Yes.
You can see the bitmap is messed up because I'm reading it upside down. But you can see how the dots of that bitmap from the field show up here. And then like here, we're driving along, right? All we do, I don't know, you probably can't see the little red dots now, but as you drive along, whatever dot you're closest to, that's the rate you pick. Simple. AB line. I'm gonna have to move this over. Okay, so we make an AB line. So there we have our basic AB line. Okay, can you see the AB form?
Yeah.
So this start is, like, you create your reference line, right? And where you want the tram line to start. Like if it's at 0, then that's where the tram line starts. And then repeats, like if we set this to say 3 repeats, like you're talking about a 3 meter seeder and a 9 meter something else. So we go okay. And then, now see can you see the dashed line? That's the reference line. So as we move along, there's 2. There, see, that one's green, so that's tram line.
Okay.
If I could drive straight. 1, 2, and then now this one will be green. 3. 1, 2, and then 3, and now this one's green. And we could send that out. And that's why I was asking about the tram line thing. So if we stop now, and if we
just going to interrupt you for just a minute. It looks like we're going to run out of time. What I could do is I could start up another meeting, and then we can continue if you want to do that. So if we just cut out, that might be what happens. But what I'll do is I'll post up another meeting on Combine Forum, and we can click on that and start a new meeting if we want another 40 minutes.
Sure.
Yeah.
Okay. It might give us 3 minutes. I'm not sure. It did the last 2 times, so we'll see if it does it the 3rd time.
Okay. So now we've set it to, I think it was 1. If we get going again.